In this problem, we're synthesizing this alcohol, and this is 1, 2, 3, 4, 5, 6. So that will be 3 hexanol. And we're going to do it in a couple of different ways and then analyze what is the best way to get this compound. So the first one in alcohol synthesis, I can do what we call a disconnection approach. So disconnected that in pieces and then put it together. So if I disconnect here, and let's go here, let me just use this thinking backwards. That's what we mean by that. So this piece, this could come from an aldehyde with 3 carbons, so it will be propanal. And here I need 3 more carbons, so I'm going to use 1, 2, 3, this alkyl halide, which I know I can make a Grignard reagent. And if I do this, after I make my Grignard reagent, that's my Grignard, I will have, add this to this compound in my Grignard reagent. This will be my nucleophile. You will have a nucleophilic attack over here. With that, so in a first step, we could get the alkoxide, and then we need a protonate. So let's draw the starting materials here. So this is, again, we're disconnecting. I disconnected into 2 fragments that have 3 carbons. One is an aldehyde, and you have 1, 2, 3 carbons. So that's propanal. And then I have an alkyl halide that has 1, 2, 3 carbons, total 6. And my idea is I'm putting those together using a Grignard reaction. And that's in a short path. So let's see. What we have here, I said that we start from then propanal plus propyl magnesium bromide. And those 2 in ether, those 2 together, let's say dry ether. And then that's my first step. That's step 1. This 2, that's ether. So, and this needs to be dry, remember. And in the second step, I need to do water. Because after this attack, you're going to get the alkoxide. So let's draw what is that in the Grignard mechanism. You will have this in 3 more carbons. That, and you need to protonate that species. That's why I need a second step. So step 1 is this reaction. Step 2 is adding water, and you get the desired product. So this is via Grignard. So I'm going to make a different pathway now. And let's think about what else can we do. But I need to use fragments of 2 or 3 carbon atoms. So, and this is what I did here, 2 fragments of 3 carbon, the molecule, the starting materials. So I can think of starting, for instance, with, say, acetylene. This is only 2 carbons. But if I have acetylene reacting with, say, first sodium amide and then ethyl bromide, I will have the following, and I can repeat that step to have, like here you have, remember, 1, 2, 3, and 4 carbon atoms. I need 6 in the skeleton of the molecule. So I'm going to repeat those steps. So sodium amide, and this is, remember, to remove an acidic hydrogen at acetylene. You have removed 1 here, you still have another. And the second step is an SN2 reaction. So here you will form the skeleton, the size of what you want. So you will have, I'm going to draw it over here, this and that. So you have now 1, 2, 3, 4, 5, 6 carbon atoms. Now I need to introduce that alcohol. So one way of doing that, we can do a hydration of an alkyne. In any region that you use is going to give you the same product. But let's say, because remember that there is the same degree of substitution, both carbons of the alkyne are substituted. So if we did here, say a hydration with sulfuric acid, and in alkynes we need to use mercuric sulfate, that will give me, remember that this go via enol, and then that will tautomerize to a keto form. So let's draw the enol intermediate first. So remember when you had an enol, you're gonna be adding across the triple bond an H and an OH. Never mind, when you put it, it's the same kind of substitution. So I'm gonna put OH here and H here. If you did that, that is an enol, so you're doing hydration of an alkyne. You get an intermediate, which is an enol, and then you will have this, you have, okay, here, 1, 2, 3, 4, 5, 6. All right, that's the enol, and that is an equilibrium, and in fact, all you isolate here is the keto form. So in the keto form, we'll have the following. So you will have here a ketone, 2 more carbons, so here, right here, and then, so 1, 2, 3, 4, 5, 6, we need 1 more. Yeah. All right, so this is what we have. So this is the tautomerization step. And as you can see, this is not the final product. That's a ketone, that's an alcohol. How do we go from here to here? That's a reaction that we have studied in the alcohol chapter, and that is a reduction reaction. That can be accomplished. So I'm gonna go now all the way up here. And the way I get here, I need another step that will be, for example, sodium boron hydride, and that can be done in ethanol product solvent or something. All right, so let's recap the step in the second pathway. I started with a molecule of only 2 carbons, and I added 2 more by doing acid-base reaction with acetylene, for removing 1 acidic hydrogen here, and then SN2 reaction. I repeated that to have these alkyne. And here I have the skeleton with 6 carbon atoms. Next, I need to add that oxygen. So what I did was a hydration reaction. When you do a hydration over to an alkyne, you get an intermediate that we call an enol, that's an enol. That immediately here will tautomerize to the ketone, the corresponding ketone. That's not our final product. We need to yet still do a reduction reaction, and that's all the arrow that I did all across the board, and you reduce the carbonyl group to the alcohol by using a hydride. You could also use lithium aluminum hydride if you do it in 2 separate steps. So dry, lithium aluminum hydride in dry ether or glyme, and then in a second step, add protonate the alkoxide. Or instead, you can simply do in situ 1 pot, say sodium boron hydride and ethanol. So analyzing the 2 pathways, let's notice that when I started with 2 fragments, I did this too. So I need to prepare the Grignard, the reagent in advance. So say I start with this. So 1 step, I need to make the Grignard, right? So propyl magnesium bromide is here. So step 1. Then I need to do actually the Grignard reactions for step 2. And after step 2, have that alkoxide and a native protonate. So 3 steps, and it looks fairly simple. And I started with fragments of 3 carbons. So here I have 3 carbon, but I needed 1, make the Grignard, 2, 3 steps in that pathway. Okay, and in the other pathway, I started with a smaller molecule. So this is 2 carbons, so step 1. Step 2, I need to add the other. Then step 3, I need to hydrate. Step 4, I need to do a reduction of the carbon. So notice that there is more than one way of synthesizing things. Selecting the pathway depends on what reaction is more efficient, giving you better yields and reagents that you have. Longer pathway, we try to simplify things, so we initially select shorter pathways, and if they have good yields, that'd be great. Grignard is very efficient pathway and is shorter, but we need to remember that we need to work very carefully and in dry conditions. The other pathway didn't have that, but we have more steps. In terms of yield, it looks good as well. So you make your selection, and you may come up with different ways of synthesizing these molecules.